Hi there. In this video, we wanted to show you the National Library of Virtual Manipulatives. This is a set of interactive technology-based activities housed at Utah State University on their website. The link right here, and this is accessible to anyone who wants to access it, is nlvm.usu.edu. There are so many things here that I could never highlight them all in a short screencast video. But one of the things, I really wanted to pick out 3 of the activities on this page that I find very useful and engaging for students as they learn mathematics through the variety of ages. One of the things that I'll mention on the forefront is a big weakness of this particular set of resources, and it's that they run on Java. And if you're using Chrome, unfortunately Java does not run in Chrome. So if you might need to go get Firefox or Internet Explorer or some other browser that will run Java. It is something that can be downloaded and used independently of the Chrome browser, but from checking it out, it actually costs about $30 to make that download happen. So I guess I'd rather be inconvenienced by having to download a new browser than having to pay $30 for its use. The link did mention that there were some additional resources that are in that download that may not be available in the online set here, so if you've got the money to spend, it might be worth checking out. One thing I'll notice to you is that when you get to this landing page for nlvm.usu.edu, the resources are broken down in a couple of different ways. Broken down by a kind of learning strand. So we've got number, sense, and operations. We've got algebra, geometry, measurement, and then some data analysis work. And it's also broken down by age level. So they've got some resources that fit the kind of the pre-K to second grade area. Here's your upper elementary grades right here. Here's what we would commonly consider your middle school grades. And then here are the high school grades. And there is some overlap in some of these. There are some activities that show up in both of these age groups specifically. That's where I spend the majority of my time as a high school teacher. Okay, the first thing I'd like to show you and share with you can be found under the 6 to 8 column in the number and operations set. So if you click this link, and what you'll see here is just a big list of interactive activities that are available to explore and to be used by students and by teachers and parents. The one I'd like to highlight to you that I found really useful is here, the adding of fractions. So I'll click this link. And here, this usually opens in a new window, and almost always I'll get a little prompt from Java saying, hey, I'm going to run this activity. It's very common for you to get the pop-up that says, we need your permission to run this applet. So here's the activity here, and one of the things I want to point out to you is that all of the activities on this resource have some links at the top. If you can provide a student with this prompt, and sometimes it will indicate what we're asking students to accomplish, but if it doesn't, the student can click the instructions box here, and up will pop over here on the right description of the instructions for this tool. So in this particular instance, we're asking students to show several things here. The first thing that we're asked to do is to rewrite these two fractions, 2/6 and 1/2, so that the denominators are the same. And obviously we're trying to model here the technique we would use to add fractions. So one thing I like about this is that students can, if they think they know how to rewrite these fractions so that the denominators are the same, they could literally just type in the responses into these blocks. Another thing they can do, though, if they're not sure, is that they're allowed to change what this resource calls the grouping of each item, which group the image is a part of. So this 2/6 is a part of the group of sixths, but if a student wanted to change the way this picture is represented, they can increase or decrease what we know to be the denominator. So something that's interesting to me here is that if a student picks a denominator that can't really be used to reproduce the fraction as given, they'll see the new choice. Here I've got this set to sevenths, and the sevenths are split up into yellow pieces, and the student can see, oh wait, sevenths doesn't really make another reasonable group out of this. Similarly, if I go to 5 now, I'm looking at fifths, and the fifths separated in yellow don't line up. And neither do the fourths. I guess I could do the thirds, because I see 3 sections here. What I'm looking to see is, does the portion of this box given to me match the size of the group, so to speak. So this visual could support students that struggle with this idea. Hopefully what a student will see with or without the technology is that by changing the blue fraction to something sixths, that we will have the same group for both. What we would hope the student would then do is to figure out that this is 2 sixths, 2 sixths, because I can count the number of parts, how many sixths there are, and if I look here that there are 3 sixths. And there's a prompt for students to check and see if that works. And of course they get the feedback that works here. Now to actually model the addition, what we've asked students to do is to drag the colored regions into the sum square and to name what the actual sum is. Notice that the sum square is also broken into 6 pieces. Again, a student could perform this operation if they know what's going on without using the tool. But if they struggle, they can literally drag the 2 sixths over into the sum square. They can drag this 3 sixths over in the sum square to model why the sum is that we have 5 pieces in the group of sixths that we're looking for. And there's a prompt to actually check that item. So something else that's worth pointing out while we have this option open is that there's always also a link for parent or teacher information that provides information on how either a parent at home can use this to support a child in learning the concept at hand, or how a teacher might use this to intervene with students that are having challenges, or to even extend the idea and to really enrich and challenge the teaching of the concept. Another thing I like on this particular device is that students can use their performance previously to choose what kind of next problem do you want. If you struggled, you might choose an easier problem. If that one's pretty good, you might continue that path. And if you've got this easily, you might want to actually go to the hardest option here, and so forth. So that's a pretty good idea of how this particular add fractions tool works out. It's a really nice setup for students in the upper elementary to lower middle school range, I would say. One of the things I like about it is that it does kind of model cognitive fidelity. We're looking for a process where the technology kind of models the thought and the reasoning that we're asking students to encounter as they accomplish the task of adding fractions. We want to try and give a visual understanding of why we need the same sized groups to add the fractions together. Okay, I'm back to the home page for the National Library of Virtual Manipulatives, and now I want to take you into the upper middle school or high school area. We're going to actually go, it shows up here in the 912 section under Algebra. And again, you have a lot of cool resources that open up here. The one I want to share with you, even though I strongly recommend this Quain problem, is a lot of fun for asking students to use reasoning skills. But the one I really want to model for you now is the algebra tiles. So I've got a clear blank space here. The thing I want to model for you that you can use algebra tiles for is asking students to multiply binomials together. So suppose I want to multiply x plus 3 by x plus 4. In doing so, what the student has here is the option to create any piece needed. So if I want to model multiplying x plus 3 by x plus 4, I want to use an area model to do so. So if I click the x, I create an x. And I kind of want to insert that here into what you might call the horizontal axis, so to speak. I said x plus 3 was one of the factors I wanted, so I will click 3 ones to kind of add on the 3 we're looking for. And what I want students to understand is that, you know, I've modeled a length here that I represent one side of the rectangle I'm going to create with x plus 3 ones, which is x plus 3. What I wanted to model multiplying that by was x plus 4. So when I click the x here, I want to fit this in the vertical setup now. But to make that fit there, I need to click one of the corners and drag while clicking to create a vertical piece, so to speak. And we said we're going to multiply it by x plus 4. So I'll click 4 ones and I'll make those fit in here. Notice the tool guides students, once they have pieces in both the horizontal and vertical columns, it guides students in what exactly needs to be filled to create the equivalent expression to x plus 3 times x plus 4. If I'm using my area model, I'm asking the students now to find the appropriate pieces that will fill this space. So what I hope students will see here is that this kind of models the idea of the multiplication chart that they were given probably in early elementary school ages. So in doing so, if I want to find the piece that fits in here, that would be the product of x and x squared. And I see that the product of x and x creates this area x squared here. The prompt I would provide for students next is to ask them what pieces might fill in this space. And if they're comfortable with the notion that x times x gives us x squared, I would hope they would also say, well, x times 1 should fit an x into this space. And hopefully a student will then say, well, I think an x would fit in each of these 3 spaces. So we can actually create 3 x's. Best we can. 2 more. And now we're going to kind of create a similar setup here where the product of each of these 1s times x should give us 4 more x's in here. Okay, so in the interest of time, I went ahead and threw those in there. My last prompt to students would be to figure out, okay, so in each of these spaces where I would have a 1 times a 1, oh, that must be a 1, right? So we're going to create 12 more 1s that fill this 4 by 3 space. Okay, and there we have it. We've completed the required area of the rectangle. So what we've shown is that another way to write the product of x plus 3 and x plus 4 is literally the expression that's modeled by what filled in the rectangle, which is x squared plus 7x, there's 3 x's here and 4 more here, plus 12. And the idea is that you could use this familiarity and fluency with the area model of multiplication to encourage students to finding the rules that do so algebraically. One of my favorite things to show students with this setup is that this filling pattern wasn't even a coincidence. It's simply that this, no matter what x is, that the product of x plus 3 and x plus 4 gives me this area model. And a thing that students can do is to use this dynamic slider here to change the length of x and to show that this model is complete regardless of the value of x.